Hello and welcome to this course on MATLAB programming for numerical computations. We are in week 10 of this course, and this week we have been discussing ordinary differential equations boundary value problems. In the previous video, I introduced you to the boundary value problems and solved an example using an inbuilt MATLAB function BVP5C. In this video, what we are going to do is to use a finite difference approach. Okay. So, recall that this is the overall problem that we had. The gamma value we had taken was equal to 4. Okay. We are going to solve using the finite difference approach. I also recommend you watch the videos from week 4. What we had covered in week 4 is that you can use numerical differentiation in order to convert your overall problem into tridiagonal matrix equation, and then we had solved it using tridiagonal matrix equation. In this video, I am going to show you how you are actually going to get that. Okay. So, and this was the next slide from week number 4. In fact, you would have also solved a home assignment problem on using a tridiagonal matrix as well. Okay. This week, we are going to talk about if you have a boundary value problem of a similar nature, how do you solve it? This was an example of a linear boundary value problem, and therefore you can solve it using tridiagonal matrix equation. If it is not linear, you'll have to use non-linear solvers in order to solve it. Okay. So, let's look at this and how do we get this. So, we'll take this entire rod. Okay. And split it into n intervals. L by n. At this point, boundary condition, and at this point also is going to be boundary condition that will be used. Okay. This we will start off with T1, this will be T2, and this will go on up to T n plus 1. Okay. So, that is what is going to happen. Now, T1 is 100. Okay. What about T2? At T2, you have d square T2 by dz square. Remember, we had said that this is going to be z. TA. Okay. This guy is going to be nothing but T3 okay. If we take h square onto this side, this is what we are going to get. Okay. So, this we can rearrange this as T1 minus this is what we are going to get. We can write this for each and every of the internal location T2, T3, T4 up to Tn, and what we are going to get is Ti minus 1 oh sorry, there was a negative sign. Minus h square gamma Ta. This is valid for I equal to 2 to n. At I equal to 2 at n plus 1, Tn plus 1 minus 25 equal to 0, or Tn plus 1 equal to 25. Okay. So, this is how we are going to have this set up, and this will be of the form a y equal to b, where y is plus 1. Okay. So, this is personally my recommended approach for solving ODE boundary value problems. Of course, you can use the the BVP 5C solver also that we discussed in the previous video, but this is personally my preferred approach. So, let us go on to MATLAB and solve this boundary value problem. This is from the previous video. Let me close this. Rod conduct FD, let me call that. Let me copy this. We have changed gamma back to 4 for the previous. Okay, let me save this and let me run this. This was what we did in the previous video. Let me run this and have the solution for us. Okay, this is the solution. Let's now solve it using finite difference approach. Okay, remember what we did over here? We just copy pasted everything. We don't need t initial, y initial. We just need the step h. We need the z probably, maybe not, actually we don't. So, a is nothing but okay. Now, first boundary condition is a 1 comma 1 is 1, b 1 is 100. Okay. So, when we had this overall equation, what did we have? We had ai minus 1, ai and ai plus 1. What is ai minus 1? Ai minus 1 is coefficient of ti minus 1. The coefficient of ti minus 1 and coefficient of ti are both equal to 1. So, I am going to write those down over here. So, this guy is 1, this guy is 1. Okay. What is the value of aii? It is negative 2 plus h square gamma. I do not want param. I will just call this as gam. Okay. Now, that is because gamma is a function in MATLAB. Okay. What is the value of bi? Bi is nothing but negative h square gamma Ta. okay, and the right boundary okay. So, this is what we are going to get. Okay. So, what is going to be T is nothing but A slash B. Okay. And that's should be it. Let's see if I've made any error or we have done it correctly. Okay, there is some problem that I have. Okay, and as you can see, it falls exactly on the previous line. Okay, so we have shown how the finite difference approach works. So with that, I come to the end of lecture 10.2 and I will see you in the next video. Thanks and bye.